I'm Gardner, and today I'm going to talk about the impact of pinyon juniper removal on reptile communities in southern Utah. And I've been working with William Heyborne from Southern Utah University and Bob Steidel from the University of Arizona. So back in 2017, William Heyborne and I worked with the Grand Staircase Monument on a variety of herpetology projects on the Grand Staircase Monument. And this ranged from the pinyon juniper removal to doing a distribution study of herps across the monument and targeting specific species. And then we also collected a bunch of DNA of rattlesnakes. And so today I'm only going to talk about one aspect of this research. Over the course of 5 years, this project really grew and expanded. So we started out on the Colorado Plateau, on the Grand Staircase Monument, and then adjacent to it, there were pinyon juniper removal treatments. And then we added sites to the Great Basin Desert. And both of these locations, we did distance sampling and mark recapture. But today I'm only going to talk about distance sampling on the Colorado Plateau, in and around the Grand Staircase Monument. The Intermountain West is dominated by sagebrush as the main vegetation, which we're all familiar with if you've been around southern Utah. So it likes cold winters, snow precipitation, and hot, dry summers is where you'll typically find it. And we have found that it's been decreasing for a number of reasons. So in 1970, it was estimated there was 155 million acres, and in 2004, it is now around 119 million acres, and similar new studies, it shows that it's also decreasing. Pinyon and juniper is also really common in the Intermountain West. So on the left, we have a pinyon tree, and on the right is a juniper tree. When we use the term pinyon and juniper, it can refer to a variety of species, and we also refer to it as PJ. So we have the Utah juniper, western juniper, single-seeded juniper. There's also the single-leaf pinyon pine, the Colorado pine, and a lot more species. So there are 3 types of pinyon juniper talked about in the literature. So the first one is this pinyon juniper savanna, which is found in New Mexico, Arizona, and you'll find that the pinyon juniper is very sparse with a grassland, and those precipitation will come as a monsoon during the summer. The second type is this persistent woodland, which we typically find on the Colorado Plateau. So it's getting its moisture during the summer and the winter. You're not going to have a lot of understory growth. It's just like very dense pinyon juniper with topography. And the third type is this woodland shrubland, where you get the moisture during the winter, and it's very favorable for shrub growth, for sagebrush, and then the pinyon juniper overstory. So we typically see in southern Utah and on the Grand Staircase Monument, we actually have a combination of a persistent woodland and this woodland shrubland. We often hear people talk about PJ encroachment, and what they're really referring to is the expansion and infill of PJ. So here on the left we have a shrubland, and over time we see that PJ has established. So we often have it expand, and then as the density increases and turns into a woodland, that is the infill. So woody plant expansion and infill has really increased in the last 2 centuries. It's been estimated that there's been an expansion and infill of 18 million hectares since the Euro-American settlement, and that it continues to expand and infill at a 0.4 to 1.5% per year. So there's a number of factors that play into the pinyon juniper expansion, and we have found that it's very site specific, so there needs to be a lot of research and site specific factors considered. So some of them could be the CO2 concentration, nitrogen deposition, the historical fire regimen. So we know that fire kills the pinyon juniper seeds, and then the changes in grazing. With the increased expansion of Pinyon Juniper, there's been a lot of effort put towards managing and removing PJ. And so in the last 2 decades, as of 2020, it's been estimated that over 2 million hectares has been removed. And there are various methods of doing this. Some of the most common is mechanical removal. So we have like mastication, lop and scatter, harrow, chaining. And they can do this in a combination with each other or in patterns to create what we call a mosaic treatment, which is highly recommended. And then there's fire, because fire is very effective for killing the Pinyon Juniper seeds, and seeding before and after the treatments to give the understory a head start and to increase the diversity. If you've been in the area for very long, you know that the removal of PJ is very controversial. And that's because, there are benefits, pros and cons to removing it. There are species that benefit from Pinyon Juniper or sagebrush. And, livestock can benefit from Pinyon Juniper being removed. PJ is a biofuel and contributes to the wildfire crisis. But PJ also supports a lot of species. It's a natural process. And the treatments are not aesthetically pleasing, but the list can go on forever and we won't get into it. There are over 250 vertebrate species in the sagebrush ecosystem. And we know there's about 70 mammal species and 18 sagebrush obligate species. But we expect this number to be low because we don't know about reptiles and some smaller groups of organisms. From a GIS study that looked at sage-grouse habitat, which is sagebrush across the Intermountain West, that horned lizards would actually benefit the most. So 5 of the 7 species were reptiles, and most of them were horned lizards in the genus Phrynosoma. This is the first on-the-ground study to look at Pinyon Juniper removal effects on reptiles. So the objective of our study here was to look at Pinyon Juniper removal on the density and species richness on reptiles, specifically mechanical treatments. In total, I have 4 plots. I have 2 reference plots. Here I have the sagebrush and my Pinyon Juniper. And then I have my treatment plots. So this is mastication and lop and scatter. These are the 2 most common methods used in southern Utah. Mastication uses a bull hog to shred the tree down, typically top to bottom. And then lop and scatter is hand cut and typically spread out and hand tossed across the landscape. So taking a look at the aerial photo, here we can see my 2 reference sites. So here's the sagebrush, and then you can see the juniper patches. And then for my 2 treatments, you can see what mastication looks like from the aerial and some lop and scatter. To pick these areas, my treatments were done between 2006 and 2020. I did not do them. They were previously done by the BLM, and they range in size from 125 to 2,000 hectares. I had 5 plots per treatment, and they were randomly selected. And then my survey was done for 2 years in 2020 and 2021. Okay, to measure density, I use distance sampling methods. And if you're not familiar with distance sampling, I'm going to give you a quick rundown. But you have a straight transect that you walk, and then for every observation, you measure the distance out to the individuals that you see. And you can use this to create a detection and a density estimate using some statistics in R. But this is the survey general method. So I had, within my plots, randomly selected transects, starting points, and a bearing to walk. And if I ever hit an edge, then I had another randomly generated bearing to then zigzag across my plots. Typically this wasn't an issue in reference because they were so big, whereas some of my treatments, if they were smaller, I had to bounce around a bit. My surveys all took place between August and September, and within 30 days of each other. So we just want to get them into a small survey season. Each survey was for 3 hours in the ideal temperature of 21 to 32 degrees Celsius, and this came out to be around 9 to 12 a.m. on average. All of our transects, we were able to hike around 5 miles, depending on the terrain. And then some of the things that we measured when we came across the lizard was the species, age class, and the time that we observed it. We also recorded any livestock feces that we came across to estimate some of the grazing influence that might be taking place in the area. We took weather data and vegetation percent cover estimates. For my statistical analysis, I did use R with the package unmarked for my models, but today I'm not going to get into this. If you are interested, please reach out. I'm happy to discuss this further. Otherwise, you can enjoy the picture of the long-nosed snake. So here's a little summary of my field results. We had a total of 349 observations with 9 species, and the sagebrush lizard was the most common species. Surprise, surprise. Here I have just a quick summary of my raw detections from distance sampling, and I'm just going to focus on the plateau striped whiptail, greater shorthorn lizard, and the common sagebrush lizard, because these are the 3 species that I had enough data on to do an analysis and modeling. So looking at the plateau striped whiptail, we see that we had the most detections in Pinyon juniper, greater shorthorn had the most in sagebrush, and then the common sagebrush lizard was pretty even in juniper and mastication, but really a lot in the lop and scatter with a few detections in sagebrush. So with the overall density of reptiles and the 3 species we were able to analyze, this table shows us the estimated density of lizards per hectare. So for the overall density and sagebrush, there were 4 lizards per hectare, and then it estimated that there were 8 lizards per hectare in Pinyon juniper, and also 8 for mastication, with 5.5 in lop and scatter. And I did round my density estimates to the nearest 0.5. For the plateau striped lizard, it was 1 plateau striped whiptail per hectare in Pinyon juniper, and then so on. So the greater shorthorned was highest in sagebrush, and the common sagebrush lizard was most common in mastication and Pinyon juniper. So density is a really important component when looking at populations. However, it's not the whole picture. So here is the species composition just from our distance sampling. Let me talk about that really quickly. If you see some of the differences, mastication didn't have the greater shorthorn lizard. It was the only site that we found a rattlesnake, which was really cool. And then in Pinyon juniper, we tend to see a lot of fence lizards. And in the sagebrush, we found a couple different ones, the leopard long-nosed lizard and the desert spiny, with lop and scatter just having 3 different species here. So distance sampling and density is only going to capture your most common species and the ones that are active during your surveys. So this is only part of the picture. Like I mentioned, we have another part of the study where we did mark recapture, pitfall traps, where we were able to see a lot more diversity and get some of the more secretive animals. From my density analysis, there are a few key takeaways. So in the sagebrush habitat, there wasn't a lot of diversity or density of reptiles except for the horned lizard population. In Pinyon juniper, it had the overall highest density of lizards and a good distribution or species composition of reptiles. When the Pinyon juniper was masticated, we found that the density stayed the same and mastication had a good species representation. So it's not hard to think that these mastication piles are providing cover from predators, shade. It also increases the moisture content. So this is good habitat. Lop and scatter can also do a similar thing, but we did see just an increase in sagebrush lizards. Note, this is for the Grand Staircase Monument in the area. This is more like site specific, and we did find different trends on the Great Basin. Another interesting takeaway was that the sagebrush lizard is a generalist, and it was common in all plots except for sagebrush. For future management projects and research, we have a few recommendations. We recommend that we use less generalization for wildlife. It's really easy to group lizards into a single group, but we need to look at their function, their use of the habitat, and their feeding patterns because it's very different. We see, fence lizards need the tree cover, and whiptails are foraging. The horned lizards are anteaters that we found a ton breeding in sagebrush. So they all play a very important role and use the landscape differently. That's where it's highly recommended to do these mosaic treatments. Here we see mastication across and leaving some pinyon juniper, probably for erosion and topography. But leaving some more intact sagebrush, lop and scatter, harrow. So smaller patches, more techniques applied in a single area. And doing longer research and monitoring projects, it's really important to start setting up monitoring to understand these ecosystems. It takes 10 or more years to get enough data and for the landscape to change from a treatment to restoring to what the management needs are and how that's going to affect the wildlife in it. I'd like to thank everybody who has helped me with this project, the Grand Staircase-Escalante partners, the BLM, the universities we have worked with, and Terry Tolbert, who started the project, William Heyborne, who has mentored me for several years, and all my technicians. They worked so hard, working early mornings and late into the night looking for snakes. So thank you, everybody. And that's it. Any questions?